On October 14, 2025, 1 week ago, SpaceX launched Starship Flight Test 11 from its starbase in South Texas. Welcome back on the SpaceInfo Club. Today, after 1 week from this triumph, we talk again about Starship, making the point, some consideration why it was a success under multiple points of view, and we'll tell you some of our thoughts, some of our discussions we had with our experts inside the SpaceInfo Club. And I'm going to let you know that one of the tests that they performed was a triumph under different points of view, and it was so dangerous that threatened the life of the ship. So booster 15 and ship 38 were the stack configuration for the flight. So a booster B15 was rolled back to Mega Bay 1 on March 8 for refurbishment, and after having flown on flight 8, it was then rolled to Pad 1 on September 5th and stacked onto Orbital Launch Mount (OLM) on September 6. B-15 then performed a 33 engine 9-second duration static fire on September 7th, then rolled back to Mega Bay 1 on September 8th and was rolled back to Pad 1 on October 8th and lifted on the OLM. So already from this you can see that the logistics is pretty complicated, and I am anticipating one thing we are going to discuss in an eventual future, I would say more technical discussion about this rocket ship. So let me know down in the comments if you want a video on a more technical point of view about this. Just let me know, and we'll talk about this with our experts. Ship 38 was rolled to the Messy test site for cryogenic testing on July the 27th, and then conducted some separate cryogenic proof tests. And after some other testing, it was installed on the OLM upon the booster B-15 on October the 11th, 3 days before the launch. So the full integration of the tandem configuration booster plus the ship, which is the Starship, occurred something like 3 days before the launch. So before going into the details of the launch and the mission itself, we can talk about the mission profile and a little timeline. As you will see, it was a success under multiple points of view, and before the launch, for sure, the something like 1 hour before, the fuel was injected, so the full booster and the Starship was loaded with the liquid methane, and very few minutes after with also liquid oxygen. It's the bipropellant combination for this ship. Then the full combination, the full load, it was completed something like 3 minutes before the launch. Then SpaceX flight director verifies that all the things are go for launch, and something like 30 seconds before the launch, everything is completed, all the checks are nominal, and everything can be considered okay or nominal for the launch. 10 seconds from the launch, 3 seconds from the launch, we have the Raptor ignition sequence beginning. Then we have lift off something like 2 seconds after the 0, so mission elapsed time for sure. After just 1 minute, the ship reached max Q, which is the maximum dynamic pressure, and after something like 2 minutes and 37 seconds, we have MECO, booster engine, main engine cut off. In this case, the main engine is for sure the booster on a super heavy, and then a couple of seconds later, we have the stage separation. And for those people that have seen the video of the launch or the full mission, well, it's always a great spectacle. They had the hot staging, which means that the ship, the S-38, stuck up on the boosters, is already burning some propellant with its own engines before detaching from the booster. This allows the ship not to lose the thrust, optimizing the whole orbit and obtaining a more optimal flight profile, which is the core thing of the whole launch. So the ship has already activated its own engines before separating, and then we have the separation from the booster. Now we have two mission profiles for two different space vehicles all around, because we have the S-38 ship and the Super Heavy booster. After 3 minutes and 38, we have the boost back shut down, and after 6 minutes and 20 seconds, we have the landing burn start for the Super Heavy booster. After a very few seconds, we have the Super Heavy landing burn shut down. 16 seconds in total, and the Super Heavy has landed. Then we have the Starship engine cut off on the other space vehicle, the one that's still flying around our planet, which is called SECO. So Starship engine cut off after something like 9 minutes, just to give you an idea of how much propellant is burnt and how fast is being burnt. Now it comes one of the core testing of this mission, what's called payload deployment demo. If you're watching this video on YouTube, not just listening on Spotify, by the way, subscribe to our channel and share this with your friends. It's completely free for you, but will help us a lot. So subscribe and just share. So after 18 and 33 minutes and 33 seconds, up to something like 25 minutes and 33 seconds, so 7 minutes in total, we have the payload dedicated mission time. So payload deployment demo, for people who still don't know, after 1 week, they had something like 6 mock-up of satellites, and guess what? Yes, they were mock-up of Starlink satellites for sure. They were, as said, mock-up, not real satellites, but they, let's say, mimicked the form and also the mass of those satellites, because the focus of this test was not testing the satellite itself, but the deployment capability, the deployment mechanism, its precision, its actually function and working behind everything. So how things could work in case those satellites were nominal. And apart from, I have to say, spreading some space debris around the orbit, the deployment was successful. And then we have the Raptor in space relight, another great success for this mission, because, yes, the Raptor successfully, I would say, relit in space, and what's coming next is the orbital re-entry of the ship, and after 1 hour and a very few minutes, 6 minutes, we have the atmospheric re-entry, the landing burn, and a splashdown. All those three subphases were also a success, and now we are going to see why they were so special in this case with respect to the other times. The new booster landing burn strategy is something that's constitute a step in the whole ladder of the Starship to the sky. At launch, the booster ignited 13 engines and then switched to a 5-engine divert configuration during its final maneuvers, a configuration that will be a baseline for future Block 3 boosters' redundancy and reliability. So why are you going to use only 5 engines when you have 13? Not because the other 8 were not working. They, as far as we know, they were perfectly working. But imagine the case as it has already happened. Most of the cases during liftoff, when you have 33 engines, that if you are working the diagrams or the screen, you sometime may have seen couple, 3, 4 engines not working on 33. The same thing can happen at re-entry. So if you have 13 of them, maybe you want to test your system, and when I say maybe, I say for sure, you want to test your system at its extremes. What happens when something goes wrong? What's the minimum number of engines that you can use in some configuration to successfully land? Well, this time was 5. We'll see in the future if they are going to test different configuration to simulate the complete or more dynamic profiles of the thing, but it was something that for sure worked, and that's a success. Another step was the elective heat shield tile removal. What does this mean? As I was saying, this was one of the most threatening tests for the ship itself. They decided, as you may have seen, to remove some tiles which are the heat shield from the S-38 ship, and in order to test how far this could go with the extreme heat of the atmospheric re-entry. You may have seen the previous landings of the ship from orbital, I wouldn't say orbital velocity because it's not yet orbital velocity, but in a configuration like that, making an atmospheric re-entry, the heat is kind of high. So for sure, if you want to remove some tiles, probably you wouldn't remove those ones which are most exposed to this heat. But guess what? Yeah, SpaceX did like that. Try to remove some of the most exposed tiles in order to test how much of that extreme heat the ship could bear, and in particular with the most exposed, some of the most critical parts, structural parts of the ship itself. And also in this case, as far as we know, for sure, as always, the test was a success because the ship survived and successfully landed. Again, one of the most fascinating maneuver that you may have seen if you have seen the video is the dynamic banking maneuver, which was executed just prior to landing. This was made in order to simulate the path that future missions which are returning to Starbase will take. The upper stage executed a subsonic banking turn before commencing its landing burn. What does this mean? Well, basically, you may want to test and to spread your flight envelope in a dynamic range, and also, I would say, in the aerodynamic range, not sustained directly or for the majority of the profile by the thrust generated by your engine, but just using the fins. This means the aerodynamic forces, which are, I wouldn't say free in terms of energy cost, but for sure far more economical, and also something that you must master if you want to extend your flight envelope also inside the atmosphere. So that's not a space plane for sure. That's one of the farthest things from being like that. But if you can control part of the aerodynamics of your brake, maybe you want also to master the use of your fins on the spaceships. So SpaceX, as far as we know, but we have seen, wanted to extend the flight envelope under the aerodynamic profile by pushing the limits of the attitude of this ship just a few seconds before landing it. So this was something which may look like as an extreme thing to be seen, but they wanted to experiment how much authority the ship has at some speed, some configuration within the atmosphere. And yes, also this was a success. But why Flight 11 really matters? Because yes, this time matters, and matters more than on the others. Well, it has been a fitting finale for Block 2, As said, SpaceX confirmed that the architecture was fundamentally sound. As architecture, I mean the whole configuration, the whole working machine, not only the structural but also this one and everything which turns around this. Indeed, it has achieved back-to-back successfuls and full profile flights, flight 10 and 11, and also it followed a string of early failures. You may remember, I hope so, that flight 7, 8 and 9 were not those success that SpaceX may have get us used to witnessing when watching a Starship flight. So this may be one of those turning points that SpaceX has get us used to. Maybe we'll see in the next flight, but for sure this was at least a starting point for a new series of success. Then this was also the validation of advanced maneuvers and redundancy. Do you remember what I said at the beginning? The use of 5 engines over 13. This means redundancy. When you have more options to do the very same thing, you use only 5 engines instead all the others to achieve the very same final function. This means that you may have more possibilities in case of one or more failures. Advanced maneuvers, dynamic banking and booster re-entry, all the flight profile. Basically the successful execution of new engine configurations, banking maneuvers, and also tire stress tests demonstrates that SpaceX is iterating rapidly and pushing boundaries of their robustness. Also, they are then preparing for lunar and Martian missions. One of Starship's critical capabilities is its ability to relight engines in orbit, and this is essential for maneuvers on the Moon and also on Mars. Think about trans-lunar injections, trans-Martian injection. This capability is not just an execution of something superficial, something that you may avoid and you do just to show how good you are. No, that's necessity. And you have to demonstrate it, particularly if you want to fly humans, that you are capable of doing this. And it seems the right path to take. Again, also, this is something that you don't have to underestimate for sure. I mentioned it at the beginning, and maybe some of you took this hint, but this is important. It's the infrastructure and everything behind the flight, which is not only engineering at its common definition, hardware, software, and space engineering in general. And also, by the way, if you are interested in this, visit the website that you see over there, SpaceInfo.club, because you may find some resourcing if you want to take a career in this that may be useful for you. But what I mean in this case is the management of the whole infrastructure, the logistics behind the launch and the preparation, because the launch was from Pad 1 and this is now slated for refurbishment to support the next iteration for Starship. Indeed, the next launches will move from Pad 1, but also one of the most important thing that SpaceX wants to improve for the future is the logistics and the management of the space vehicles, which are on one side built from factory, on the other side, coats just after landing, and in a matter of days, hours, in the far future, they must be completely refurbished and then got ready for a new launch, as you do for a conventional airliner. This is the idea, and for sure you will understand that managing all this operation is a huge logistic maverick. So what's next? What are the challenges and the risks? One of those is the boost backbone showed a slight deviation. Indeed, as I said, this is a huge triumph for SpaceX and also for the engineering behind this thing. But well, probably you may want to take a look of those very small things that didn't work properly, because they can become bigger next times when they scale up, or maybe they're just a hint of something that's not working 100%. And when you have a flight heritage of just 11 flights, not 100% successful by themselves, maybe those very small percentages may give you a hint of what you have to take care of in order to improve when numbers will get bigger, because 1% of 10 is something, but 1% of 1000 is something much bigger and may become relevant when you are flying humans. So only 9 out of 10 engines are elite. This is one of the risks or challenges, or something that may not work always in the future. One thing. Second thing is the selective removal of heat shield tiles, because this was very much a source of learning, but may also reveal unexpected vulnerabilities. I wouldn't say this. I wouldn't define this 100% as a risk, because it's a calculated risk when you are voluntarily removing some tiles, but this would highlight some weaknesses in the structure of the spaceship. But on the other side, you are looking for those weaknesses, because you want to find them out before they become critical, before you are flying humans, you are flying to the moon, to Mars, because those may be real problems. So yes, they selected to remove some heat shield, some portion of it. Maybe in the future they will repeat with other portions of the shield. We will see. For sure, it's important to find out all the vulnerabilities that you can, and testing is the most relevant part to find them out. Analysis, design, all other analytical methods that you may simulate in your lab within your computer are one thing, but then you have to get out and test those things in the real world. And this is one of the most brutal but most effective way of doing this. And finally, now we have the transition to Block 3 version 3. We are going to encounter some scaling challenges. Maybe the percentages will remain the same. I suppose not, but even those percentages remain the same, scaling up the numbers would become absolutely bigger. This is one thing. The challenges may become bigger. For sure, some lessons learned, they have put them under their belt, and the future is here. We are looking for the next launch, longing for it. Let me know if you want a more technical analysis, looking some aspects of the launch or the ship more in general. Just let me know. Thanks for watching. See you in the next episode.